Good afternoon, everyone. My name is Huili. I'm a PhD candidate in the Department of Biomedical Engineering here at Northwestern. Today, I want to share with you how AI can help heart doctors save more lives. Before we start, I want to give everyone a challenge. Could you please try to hold your breath for 10 seconds? I will take the time. So now take a deep breath and hold it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.5, 1.4, 1.3, 1.2. All right, you can breathe now. Remember how this feels, because today I want to introduce to you a technology called cardiac magnetic resonance imaging, or cardiac MRI. It is one of the methods that doctors use to take pictures or videos of your heart. During a cardiac MRI, the patient will be asked to hold breath for 10 to 15 seconds long, repetitively over 1 hour procedure. It is hard and exhausting, even for healthy people, let alone people with heart disease. And there are patients who cannot hold their breath because of health issues. Even though these might be the ones who need a cardiac MRI the most, they don't get one because they cannot hold breath. So what would happen if a person failed to hold breath during a cardiac MRI? When we breathe, the heart moves with the lungs. And trying to have a cardiac MRI when you are breathing is like taking a picture of a moving train. It is moving so fast that it cannot get a clear image. And doctors would not be able to make accurate diagnosis from such images. Luckily, we now have a new technology called real-time cardiac MRI, and not requiring people to hold breath is one of its advantages. You might be thinking, if we already have the kind of MRI that doesn't require people to hold breath, why are we still using the breath-holding one in the hospitals? It turns out the ability to avoid breath holding is not free. The cost is much longer processing time because the current real-time cardiac MRI relies on complicated computer algorithms to process data. It often takes around 15 minutes to process one single video, while the typical cardiac MRI requires dozens of videos. Patients who have heart disease and who are anxiously waiting for diagnosis, they don't have the time to wait. And doctors who have a lot of patients, they don't have the time to wait. This long processing time has made real-time cardiac MRI unrealistic for being used in the hospitals. But there's a solution, or a potential solution. In our lab, we are trying to use artificial intelligence, or AI, to deal with this issue. Now the question is, what is an AI? You might be thinking about the fancy robots or the smart machine that could try to kill us and dominate the world, like in many movies. But in our lab, the AIs look like this. There are a couple of computer programs that we designed to deal with specific tasks. For this specific study, we try to use AIs, train them, and ask them to convert bad MRI images to good ones. How do we do this? AIs learn the way that people do. They learn by repetition, by trial and error. Once we've built an AI, meaning we've written the code and stored it in the computer, we will give it a bad MRI image and also the corresponding good image that is calculated using the complicated algorithm. At first, the AI sees the images, it has no idea what is going on. It is all confused about how to convert such a bad image to such a good image. But after a few more months of training, it started to get some idea. And finally, after more and more training, maybe 1,000 rounds of training, it will become an expert at generating good MRI images from bad ones. The reason we are doing this is because once we have a trained AI, it doesn't require 15 minutes to deal with one single video. Instead, it only needs less than 1 second. Imagine if we have such a trained AI integrated into the real-time cardiac MRI system. It would become a great replacement of the current breath-holding MRI. And patients who cannot hold breath can now have cardiac MRI. For everyone who is going to have cardiac MRI, instead of trying to hold your breath repetitively over 1 hour, what you would need to do would be to just relax. This is my research. Thank you.